So from here, this is what you're going to be clicking. So configuration. When the configuration comes up, there are a couple of options that you have here in order to set up your PWM, in order to create your PWM signal based on the frequency that you needed. So on this lab, we needed, according to the data sheet for the buzzer that we have, we need to have 4 kilohertz frequency. So that's what we are trying to achieve using the Labjack control panel manually. So how are we doing it? So there are a couple of things. First one is you need to enable a timer. So enable one timer. Once you enable one timer, the timer 1 becomes enabled. From here, you can choose the timer mode. There are 2 modes that we will be using for our lab purpose. It could be either PWM 8 or we will be using PWM 16. So let's set it at PWM 8 for the time being. And there are 2, the timer clock base, this is what TCB that we call. So when you click on the TCB, there are multiple options that we have. 4 megahertz, 12 megahertz, 48 megahertz, and 1 megahertz per divisor, 4 megahertz per divisor, and so on and so forth. And there is a reason why we have the divisor and why we don't have the divisor on the top 3. I'll come back to it. Let's set it at 48 megahertz per divisor for the time being. Once you enable the 48 megahertz per divisor, that's when the timer clock divisor becomes enabled. If you are to set it up at 48 megahertz, there's no divisor, right? And only when you set up anything with the divisor, that's when the divisor becomes enabled. So for our lab purpose, we need 48 megahertz per divisor. So I'm going to set that 48 megahertz per divisor. And here, according to the lab, we set it at 48, right? And what we see here is the duty cycle. So the duty cycle, we can adjust according to the lab. According to the lab, we need 50%. So 100%, it is going to be, if you put 65,536, that is the 100%, sorry, 35. And then for our lab purpose, we are sitting at 32,678. All right, so that's what we say. Now, what is this one here? This is the pin offset. The pin offset, there are, according to the Labjack control panel, you can see we will be using one of these pins, one of the FIO pins, flexible input output pin. That is the pin that we will be using in order to configure our PWM signal. On this lab, we are using FIO4. So FIO4, in order to send the signal from the FIO4, we need to set the pin offset to 4. For example, if you're going to send the signal from FIO5, then you would change it to 5. If you're going to send it from 6, then it would be at 6. Okay, so for the lab purpose, we will leave it at 4. And so this is all the setup that you need in order to create the frequency that we needed. So now I'm going to show you something on the blackboard here, or the whiteboard here. The calculation for the frequency is equal TCB divided by timer mode times divisor, right? This is what the calculation for the frequency. So in this example here, okay, side by side, so we can look at it. Okay, so in this example, what we are looking at is the TCB. TCB here, the TCB here is this one. Which one? Timer clock base. So that one, that number that we are looking at. So it says 48 megahertz per divisor. So that's going to be 48 megahertz when we say it, 10 to the power of 6. Okay. divided by timer mode. What is the timer mode here? Timer mode we have here is the PWM 8. So when we say PWM 8, you cannot just put 8 there. It is 2 to the power of 8, which is equivalent to 256, right? So that's 256. I'm just going to ignore this one here. Instead, I'm going to consider the 256 as the number. Okay, and then what we have is the divisor, right? So the divisor here is 48 according to the lab, right? So I'm just going to put 48. Now, if you are to do the calculation, 3,906.25. So this is equal to 3.9 kilohertz, right? So we need 4 kilohertz. So this is pretty much, we can say, if you round it up, the buzzer needs 4 kilohertz according to their the data sheet. So this is, we can safely say this is equal to 4 kilohertz, right? So now that's all well and fine. But the thing is here, the divisor. Why do we need the divisor, right? Why can't we, like, even though we use the divisor at the top, 48 megahertz per divisor, there's nothing much we are doing with the divisor other than adding another number here, right? So instead of using the divisor, we can just set it at 48. If you are to set it at 48 without a divisor, what is the answer for this equation? Okay, so let's look at that once again. So the frequency in our case now, TCB, TCB is now 48 megahertz, right? Divided by, there is no divisor, but we have 256, right? That's all we have. So with this, get 187,500, right? And if you are to convert that in kilohertz, it's going to be 187 kilohertz, right? So let's say you have a device that you need to set, you need PWM signal to operate that device. And that device, according to the data sheet, they needed, or the manufacturer needed about 200 kilohertz. That's what the operating frequency is for a particular device. If that's what the case is, we have about 187 kilohertz here. So this is, we can safely say this is roughly 200 kilohertz. If that's what the case is, then this equation here is totally fine. Now, at that point, we don't need the timer clock base here, right? So the reason why we have the timer clock base per divisor is to get a signal that satisfies our needs. So for example, we can look at another example here. So I'm just going to pick, let's say we need a frequency that is, our frequency for a device that we are going to be using is, let's say it's 8 kilohertz. That's what we needed. So we can rearrange the formulas. So frequency is TCB divided by timer mode times divisor. This is the formula that we have. And we know the frequency that we need, it's 8 kilohertz. So what I'm going to do, I'm just going to rearrange the divisor. The divisor is equal to TCB divided by timer mode times frequency, right? This is how it will look like. So let's go back to the original example or the original equation that we solved for 4 kilohertz, right? So when we use the original setup, we got frequency equal 3.9 kilohertz, right? So let's rearrange, let's put this equation in here and see what we get for devices. So we got 48 megahertz divided by timer mode, which was 2 to the power of 8, which is 256, times frequency, we got 3.9 kilohertz, right? So if you are to apply the math here, you would get divisor is about 48. So that's what we set up there. So this is the reverse engineering. Now, let's say, as I said, if your device needed 8 kilohertz and you need to set up this configuration here, or the function generator here, to generate 8 kilohertz, how would you pick the number? So you set everything up here, the 4 megahertz, or maybe we can pick 12 megahertz, right? 12 megahertz per device, and we can choose, let's say, 16 PWM. So if you are to apply that and then leave the device, and let's see how much we need to set the device with this setup to generate 8 kilohertz, right? So let's go for that. So there you go. So we have, we don't know the devices, so the device is going to be here. We have TCV divided by timer mode times frequency. We know the frequency, right? So TCV is we set to 12 megahertz this time, divided by timer mode. We set at 2 to the power of 16, because that's a 16. The PWM here is the 16. And then the time, the frequency, we know it's 8 kilohertz, right? So if you are to resolve this equation, we can find the device. This is the number that you get, right? So the divisor does not take any decimals. The divisor only takes numbers from 1 up until 256. So this is not going to really help us to achieve the 8 kilohertz that we need. So in order to achieve the 8 kilohertz, now we need to rearrange this number with whatever that is possible here. So I'm just going to change what we can change here. Instead of having 12 megahertz, I'm just going to change it to, let's say if I can drop it to 256 instead of 65,000, I mean 2 to the power of 16, right? So let me put the calculation once again to get 5.859 some change. So what we can do is, if you are to set up the divisor at 6 with this setup, this will produce 8 kilohertz, right? So as you can see now, let's rearrange the formula. We'll go back to the original formula once again. I know you guys probably know about that, but just to make sure that everyone understands. So frequency here with this setup, we're going to have 12 megahertz, right? 10 to the power of 6 divided by, and I have the timer mode is set to the power of 8. So that is 256 times, and I have the divisor set to 6, right? So as you can see, 12 megahertz, I have 12 megahertz per divisor set. And then here I have 256 because it's the mode is PWM 8. And then I have the timer clock divisor is set to 6, 7,812. So, you can say this is roughly about 8 kilohertz. Or if you want even more precision, then we can rearrange, or we can play around with this number until you get the exact number or the precision that you're looking for, right? So the takeaway here, the divisor here is helping us, or not just the divisor, the TWM mode that we have here, and the multiple devices that we have here, all helps us to find out the sweet spot, right? Whatever the number that we want, we can achieve by changing any numbers here to get the frequency. You can, in this example, we looked at 8 kilohertz here. If you want to find 12 kilohertz, what would you do? You set everything accordingly. Maybe you can put it to 16 and then 48 here, and then now play around with the number. You already know the frequency that need is 12 kilohertz. So apply that number in this frequency and find the divisor to get the intended signal. So now we know why we have the divisor and why we don't have the divisor. So if you don't know, if you don't need to play around with the number, you just get whatever that you want to. So also with this setup, you have the, if you apply this number here, then it'll be 48 10 to the power of 16 divided by 65,536. That because that is the timer mode that we set, right? So whatever the frequency that you get, if you're satisfied with that, then there is no divisor needed. If the divisor is needed for you to achieve the right result. So that is that. Now, how we are going to program this on for the lab purpose, right? So there are a couple of things that you need to look at here. So the first line here, as you can see here, what that actually does, it pin offset, right? We are offsetting pin to 4. What that really means is this one here. What we are doing programmatically, we are setting the pin offset to 4. For example, if you need to send the signal from FIO pin 5, then in the program, you would change it to, this one will be 5 instead of 4. All right. So the other one here is the timer clock base. So the timer clock base is set to LJ timer clock 48 megahertz per divisor. All right. So pay attention to this one. This is set to 48 megahertz per divisor. Where is it in the actual program? This one here. The timer clock base is set to here, is set to 48 megahertz. But what the program says there is 48 megahertz per divisor. So if you do not need the divisor, for example, right, then you would set it to LJ something like that. Okay, so that will be just 48 megahertz. If you're choosing that on the program, on the control panel, if that's what you want, then the code is going to say the same thing here. It will be at 48 megahertz. But what we are actually setting is with the divisor. So it has to be with the divisor. The other ways is the timer clock divisor is set to, now we are setting the divisor. This one timer clock base is set to 48 megahertz per divisor. The other one is the actual divisor. So the divisor is right here. So once we set the per divisor, and this one here, we are setting to 48. So that's what this line of code is indicating. And then we are moving on. The timer is enabled 1. This one here, as you can see, that is the timer is enabled 1. And then the PWM signal, I'm sorry, the timer mode. In this case, the timer mode, as you can see, input timer mode is set to LJ timer mode PWM 8. And if you need 16, you can change it to 16. Well, according to the program, we need 4 kilohertz so that we can leave it at 8. So that's what this is, right? So what this program, the codes from section 3 up until section 7 does is we are setting the exact configuration on the control panel using the codes. Once all of them set, we are sending it to the device using the LJ, the go command, right? So all these setups got assigned into the LJ queue in an array. And then when we send the go, it all goes to the device. So that's what I want to bring it to your attention, so that you'll understand, or you know, the setups on the Labjack control panel itself, setting it up manually, and the reason of the divisor, with the divisor and without the divisor, and then what the codes actually mean. Thank you for watching.